I love books. I enjoy reading a lot, and I always look for books that are thought provoking. Those books that provide insight that when you read them for the first time, you're taken aback. And as you start thinking about what you just read, you start wondering, that is so obvious. Why didn't I ever think of that? And as you apply these tips and or insights, you notice how you become more productive, more efficient, or even happier in your life. So in this video, I want to do the same. I want to share tips and insights that will help you develop a game engine quicker and more efficiently. My name is Jero Serrano, and one of the things I'm very passionate about is 3D game engine development. I actually developed a 3D game engine. It took me 5 years of hard work, so believe me, I know how hard it is. And I'm here to share with you everything I know about game engine development. So let's begin. Alright, so what I'm going to show you today is I'm going to share with you some useful tips and insights that I have accumulated over the years throughout the development of my game engine. I hope they are useful. So let me share them with you. All right, so the first insight that I want to share with you is the game engine development is basically 75% programming and 25% art. I know that doesn't seem to, what many people would think of when they think of game engine development. But I learned this the hard way. Actually, in the beginning, I would buy game characters and I tried to render the characters using my primitive game engine that I had back then, and it didn't go so well. I would spend hours and hours trying to figure out the problems that were arising. So against my will, I was forced to learn 3D modeling tools. I started learning more about Blender 3D, and some of game some artistic concepts that I needed to learn. And what happened was that as I learned 3D modeling techniques, computer graphics concepts, they started to make sense. I understood why we needed the UV coordinates. I understood what is how the armature is used to animate a character. I understood what is a bone vertex weight, which is used for animation. I ended up understanding so much about computer graphics, and as a result, I was able to improve my game engine, know its limitations, and make it better again and again. So one tip I recommend you to do, and I know this you are not going to find this anywhere else, but I strongly recommend you to take some time to learn 3D modeling tools such as Blender 3D. Learn the workflow that game artists use, learn their modeling techniques, etc. Believe me, it's going to pay off tremendously. All right. So that's my insight number one. Let me go to insight number two. And this is more about architecture overall. All right. So keep this always in mind. A class should have only one responsibility. All right. Let me give you an example. A game object, such as the character that I have here on the screen, can have several behaviors and properties. It needs to be able to send information to the GPU so that it can be rendered. It needs to be able to detect collision. It needs to determine its final velocity after force has been applied. It needs to create the illusion that it walks through animation and etc. And your instinct may be to make the game object responsible for all of these operations, but do not do that. Instead, delegate these behaviors to other classes. All right. So, for example, in my game engine, a game character inherits its properties and behaviors from all of these different classes. And what I do is this, like the U4D entity class that I'm highlighting here, it contains the local and absolute space of the character. However, any linear algebra operations are delegated to the transformation manager. All right. So if the character needs to rotate, that operation is not done by the U4D entity class. That operation is delegated to the transformation manager class. That's where the whole mathematical operations happens. In the same token here, the U4D visible entity class, it provides virtual functions that will be overwritten by the game character. However, all of the rendering operations are not done by this class. They are done. They are delegated to the rendering manager. All right, and let's say that you want your character to have an animation, right? Well, the U4D model class doesn't take care of the animation at all. The armature manager takes care of all the operations related to 3D animations. It takes care of all the bone transformation. It takes care of the bone vertex weights. It takes care of everything related to animation. The U4D model is responsible for other stuff such as the attributes, such as textures and the vertices and normal stuff like that, like storing data for the model, but it doesn't, it doesn't perform any animation operations. It delegates that operation to the armature manager. So always prefer composition over inheritance, right? Basically, your class should have only one responsibility. If your class requires an extra behavior, well, delegate that behavior to another class, and that's going to make your game engine more modular and flexible. All right, so that's my insight number 2. Insight number 3. Now, I know that some people may object to this, and that's okay. But if you read any object-oriented programming book, you will find a section dedicated to data encapsulation. And data encapsulation states that data members should only be accessible by set and get methods, and that they should be private. Now, this is a rule to always keep in mind, but from my experience, you should break this rule when you are developing a math engine. All right. Now, why do I say this? Well, let's say that you want to develop your math engine and you want to use the set and get method. I think they're called setter and getter. And let's say that you want to do a simple operation such as adding and then dividing. Your code is going to look like this, right? And one thing that a game engine requires is a lot of mathematics, all right? And you do not want to have your code looking like this: v that get x plus v that get y times a that get y divided by a that. You don't want that. That looks like a mess, and believe me, it's going to get complicated to even read what's going on. So instead, you should break this rule of using setters and getter. All right, rules are meant to be broken, right? But only if you know what you are doing. So I strongly suggest to not use setters and getters in your math engine. All right, don't do that. Instead, just access the data members as as if they were public. Okay, so instead of doing v.getX, just do v.x plus v.z times a. Believe me, this is going to make your life easier, because when you get to the physics engine, when you get to the collision detection system, you will be doing a lot of mathematics operation, and the last thing you want to do is be doing getter and setter and stuff like that. Don't do that. Don't do that. Break this rule. All right. So that's insight number 3. Insight number 4. Oh boy. Use tolerance when you are comparing floating point values. Now, keeping this in mind is paramount. All right. Don't forget this rule. Let me give you an example. The sensitive nature of the algorithms involved in collision detection requires a robust numerical comparison, right? Else, you may end up missing collisions. All right. I ended up wasting several weeks of development because I didn't follow this advice. In one instance, I had several objects colliding, and everything seemed fine except that now and then the engine would miss some collisions. And what made it strange is that it would only happen at particular angles, and it was intermittent. Right? Sometimes it happened, sometimes it didn't happen. And after weeks of debugging, I found the problem, right? The problem was that I was comparing floating point values as if there were integer point values. And that was causing the collision detection to miss collisions, right? So my tip for you is do not compare numeric floating point values like this, all right? I made this mistake. It's like insane. I know it's dumb now that I look back, but I learned something, right? What I learned was that when you are comparing floating point values, you really want to use a tolerance, right? You want to use something like this. You want to have an epsilon value, because collision detection is so complicated, and it's not an exact science per se, and I'm gonna talk about that in a few seconds. So site number 5, collision detection. All right, so collision detection boils down to knowing computational geometry. All right, it's about learning theory of convex sets and geometric algebra. It's about determining if a point lies in a convex hull. It's about determining on which side of a plane a point is located. It's about determining the closest point to a tetrahedron, etc. All right. So collision detection is all about computational geometry, convex sets, and geometric algebra. That's what it is all about. When I started developing my game engine, I thought that the only math I needed was linear algebra. Well, I was wrong, very wrong. See, when it comes to implementing a rendering engine, then you do apply linear algebra concepts. But when it comes to collision detection, it's all about geometry. All right. So let me give you some tips that you should keep in mind when you are actually working on your collision detection system. Tip number 1: start small. All right. You may want to start small. And what I mean is that implement collision detection with spherical volumes first. All right. So I know that you want to have a very cool collision detection system that can detect any shape. don't, don't start out that way. Avoid using convex holes volumes during the beginning. And why? Well, the problem with collision detection is that you don't know what you don't know, right? Uh, Collision detection is an art as much as it's a science. It is simply a new language, so to speak. For one, you need to be very comfortable with computational geometry. Secondly, you need to familiarize yourself with collision detection algorithms. And thirdly, collision detection requires a vast amount of peripheral code. Um, Most of them are related to computational geometry. For example, you are going to need to determine if a point in space lies within, like inside a tetrahedron, right? And that takes a lot of peripheral code, and that takes a lot of time to implement. So my tip to you is this: start small. Implement a collision detection system that uses spheres as bounding volumes instead of convex holes. Um, it would not give you a precise collision, right? But it will get you comfortable with various algorithms. All right. So actually, here I have a small graph that shows that the spheres in comparison with a convex hull. Obviously, convex hull is going to give you a better, a more precise collision detection when compared to the sphere. But when you're starting with a collision detection, you want to start with the spheres first, not with the convex hull. All right, and that brings me to my second tip. Start slow. All right, implement collision detection with non-moving objects first. All right. See, implementing a collision detection system is all about taking baby steps. It is about learning little by little as you fall. Don't rush into implementing a collision detection algorithm suitable for moving objects. All you will be doing is opening a Pandora box, right? So start small and slow. Implement a collision detection system suitable for static objects first. Well, doing so will pay off, and you are not going to go nuts. All right. And insight number 6: visualize the algorithm before implementing it. All right. Believe me, this is such a big one. All right. Visualize the algorithm first. All right. Don't when you see an algorithm, when you are reviewing an algorithm, don't just copy and paste it. Don't do that. Visualize it, see it. See it first, and then open up your computer and code away. Right? See, I'm a visual person. If I can see the problem, then I can find a solution. So what I do is I actually scribble down the algorithm that I'm about to implement. I draw pictures showing the flow steps of the algorithm. I even scribble the problems that may arise at a particular scenario, and only once I have a really good idea on how to implement the algorithm, that is when I get in front of my computer and I start coding. I start typing away. Actually, here I have a screenshot of my notebook when I was trying to implement the AI system, the artificial intelligence system. More specifically, behavior, a steering behavior for the characters. So now if you are not a visual person, this trick may not work for you, right? But nonetheless, you may want to try to do something similar. Go take a long walk, go for a hike, go ride your bike, go play soccer. And as you are doing these activities, think how you may implement the algorithm. Try to visualize the algorithm. Try to see any flaws in the algorithm. And once you are ready, fire up your laptop and go that way. You'll be surprised. Sometimes I'm playing soccer. I'm like running, after the ball, right? And I'm actually, this is so true. I'm actually thinking of how I can break the algorithm, right? Thinking of ways of how, a bug, how a bug may arise in scenario. I think about corner cases. I think about everything about the algorithm. I can be, driving to work and I'm thinking about the algorithm, but I think in a way of like, how can I find flaws in my own logic? And once I find them, I fix it right in my head, and it helps a lot. And it may seem as if you're wasting a lot of time, but I found out that when I do this, I end up with fewer bugs to fix. So give it a shot. You may end up being more productive. All right. And insight number 7. There is no one specific way to develop a game engine. All right? There is no one way. There is not the ideal way to develop a game engine. All right? When I started developing my engine, I would take what I was reading about game engine development as gospel, right? I didn't allow my imagination to fly. I wanted to do something complicated, and I was afraid to fail, right? So during the beginning, engine development felt like a chore, until I realized that the beauty of game engine development is the fact that there are thousands of different ways to develop a game engine, and that no one, absolutely no one, no person knows the right way to develop a game engine. All right? Yes, there are best practices that you should follow, but there are no hard rules that states how to do it. All right? And that was the moment when I felt in love with game engine development. At that moment, I became free intellectually, and I started experimenting with my own ideas. I read articles, I read books, but I don't take their content to heart. Instead, I just see whatever I'm reading as a suggestion, and I read it from multiple sources. I analyze different code snippets, and once I feel ready, once I visualize the algorithm I'm going to implement, I go on and I implement that particular feature the way I think it should be implemented, not how someone else is telling me. All right, I do it my way, not what the book says, right? So don't think there is one correct way to develop a game engine. There are plenty of ways, and your job is to find your way of developing your game engine, right? And I think that's the beauty of engineering, right? That's when when you have your knowledge, your technical knowledge, and you can merge that knowledge with your imagination, right? And then come up with novel ways of how to solve a particular problem, ways that nobody has ever, ways that no one has ever thought about, right? That's the beauty of it. So, insight number 7: do not take what you read about game engine development as gospel. All right, I have a lot of articles on game engine development, and read them, right? Learn from them, but don't think that that's the way to do it. you can find better ways to develop your game engine, right? So again, there is no one way to develop a game engine. There are thousands of different ways. All right. So that concludes what I wanted to share with you. Let me go back. And I hope that these insights and tips, are helpful to you. I when I started, I knew nothing about game engines, so all of these tips and insights, there are things that I have accumulated, throughout the whole development. Right now, when I look back, they all make sense, but when you don't know what you don't know, then you don't know. So, but I'm sharing this with you so you don't make the same mistakes that I did. All right. Thank you guys. Thank you for stopping by to watch this live stream. And I hope to be here soon again. Thank you.